Hey guys, welcome to Unit 9, Lesson 7. Our topic today is position, velocity, and acceleration, free response problems. So I want you to pause the video and try the warm-up. The warm-up says the graph below shows the position of a particle moving along a horizontal line. So it's asking us to describe the motion of a particle from 0 to 4. So remember, whenever we say motion, we're talking about how the particle is moving to the left, right, and is at rest. So it will be based off what velocity. So it is at rest when velocity is what? Equal to 0. It moves right when velocity is greater than 0, and left when velocity is less than 0. So how do I use my position to come up with velocity? This is a velocity, not a velocity graph. So what I'm going to try to do is I'm going to think about slopes, right? Whenever my slope is increasing, it's going to be to the right. Wherever slope is decreasing, it's going to be to the left. And where it's at rest is going to be wherever my slope is 0. So let's start with that. So if I look at my graph, it's at rest at what here? Right, when my slope is 0. Where is my slope? 0. My m is equal to 0 here and here. So what are those 2 points? Those are at t equals 1 and 3. So at t equals 1 and t equals 3, the particle is at rest. Now I want to actually start tracing them because that kind of I feel helps. So if I look from 0 to 1, what's my slope? It's positive, right? So let's write that down. This is positive slope here. So from 1 to 3, I'm going to write this 3 here. What's the slope? It's going down, so it is negative here. And from 3 to 4, it's positive again. So now all I need to do is write it down. So it's moving right from 0 to 1. And where else was the slope positive? From 3 to 4. And it's moving left is from 1 to 3. So that's the motion of your particle. Part B. It's asking us to sketch the graph of s prime of t. So our s of t was our position, and we know the first derivative of our s prime of t is your velocity function. So how are we going to sketch using our s of t? So basically we're going to use the slope values to sketch it. So first we start with, where was my slope in my original graph? 0. It was at 1 and it was at 3, right? Now from 0 to 1, we're going to identify each interval and see what was happening to the slope. So from 0 to 1, it was positive, means what? My derivatives is going to be above the x-axis. From 1 to 2, it's decreasing, and 2 to 3 is also decreasing. So can I say 1 to 3, it's decreasing? So it's going to be what? Below the x-axis, right? And then from 3 to 4, it is increasing, so it's going to be above the x-axis. So this is what it's looking like. So let's write this down. The velocity is decreasing from 0 to 2, and velocity is increasing from 2 to 4. Okay, now it's asking us to sketch the graph of s double prime of t. S double prime of t is basically your acceleration, right? So I'm going to write it as a of t. So again, we're going to be looking at the slopes of what? My velocity. So if I look at the slope of my velocity, which is my part B, I can come up with the sketch of s double prime of t, or my acceleration function. So again, how do we do this? We are going to be looking, where is our slope equal to 0. So our slope is 0 over here. My m, I could have drawn a tangent more closer to this here. You kind of get the idea, right? My slope is 0. So what is that? At t equals 2, my slope is 0. Now if I was to trace the left side of this, what is happening to my slope? My slope is what? Negative here. And if I was to trace the right side, from 3 onwards, it is what? Positive. So if it's negative means what? It's going to be below the x-axis, right? And if it is positive, which is from 2 to 4, it's going to be above the x-axis. So that kind of gives us our tentative acceleration graph. So velocity is decreasing, or not velocity, acceleration is negative from 0 to 2, and acceleration is increasing or positive from 2 to 4, right? That's how you would sketch these. So let's kind of quickly analyze this. Let's say tentatively, this looks more like a cubic function to me, my original. It's like a cubic function. So let's say it was y equals x cubed, right? That's like kind of a cubic function. And now if I was to take a derivative of an x cubed function, that would be what? X squared, which would be a parabolic graph. And if I look at the first derivative, I did get a parabolic function here, right? And if I take the derivative of this one, of my b, which the derivative of x squared is just x, which would be kind of a line. So if you were to analyze it, it kind of makes sense. I'm not saying that this function is y equals x cubed. I'm just giving an example, just giving the idea of what the derivative of each one would look like given the original function. So let's move on to the next page. So here in these questions, we're just like gonna analyze what's given to us and answer them based on the knowledge from our previous lessons. So it says a squirrel starts at building A at time t equals 0 and travels along a straight wire connected to building B. For t between 0 and 18, the squirrel's velocity is modeled by the piecewise linear function defined by the graph below. Again, I've always said that you need to identify what graph is given to you. That is one of the most common mistakes, because what is given to you will affect how you look at it, right? So this is a velocity function. So this is a velocity graph given to us. So at what time, part A, at what time in the interval from 0 to 18, if any, does the squirrel changes direction? So when does a squirrel changes direction? When my velocity changes what? Signs. So I always like to do, again, go back to your definition. The definition helps you find the answers to these questions. So where is velocity changing sign? So if you look at it, it is at t equals at 9, and the other one is 15. So, right? So let's answer that. That's part A. T equals 9 and t equals 15, right? It went from positive to negative and negative to positive. And my reason was when v of t, or velocity, changes signs. Okay. So now part B. Describe the motion of the squirrel in the interval from 0 to 18. Explain your reasoning. Again, motion means what? You're moving to the right, left, and at rest. So let's write that down. Rest, right, left. When is it at rest? When my velocity is equal to 0. It's moving right when velocity is greater than 0, and left when velocity is less than 0. So it is moving, it is at rest. We just did that at what? T equals 9 and 15. t equals 9 comma 15. Moving to the right is when it's above the x-axis, so that is from 0 to 9, and then from 15 to 18, right? And then the last one, it's moving left, is from 9 to 15, because that is the time when it is below the x-axis, or y is negative, if you want to think about it like that. Part C, when is the distance increasing and decreasing? So basically we're asking for the change in distance is basically asking for change in velocity, which is same as part B. So I'm going to just write that down. C is what? It is at increasing. Distance is increasing from 0 to 9 and 15 to 18, and decreasing from 9 to 15. Okay, part D. I'm going to take it here so that I don't have to slide it down. So this one. When is the squirrel speeding up, slowing down? So whenever we talk about speeding up and slowing down, we are comparing, we're making a comparison between our acceleration and our velocity. So remember, so let's go up to the graph and kind of trace it over each interval and find out what's happening to my velocity and acceleration. Again, remember, this is a velocity graph, so since it's above the x-axis, velocity is going to be positive for the entire time when it's above the x-axis. And to find out what is happening to my acceleration, I'm going to be focusing on my slope. So my velocity is positive and my acceleration is what? It's positive. Here my velocity is positive, but my acceleration is what? Equal to 0. So it's not increasing or it's not speeding up or slowing down. So it's neither here. From 7 here, my velocity, to 9, my velocity is what? Decreasing, but velocity is, sorry, increasing, it's positive, and my acceleration is negative. Then from 9 to 10, my velocity is negative, and so is my acceleration negative. From 10 to 14, we really don't care because it is at rest, so we're not talking about it. From 14 to 15, my velocity, again I'll say that velocity is, because it's below the x-axis, so it's going to be negative. And if you look at the slope, the line's going up, so your acceleration is positive. From 15 to 16, your velocity is above the x-axis, so it's positive. Your acceleration, the slope is positive of the line, so acceleration is also positive. Okay, so wherever we have the same signs, we are speeding up. Where we have opposite signs, we are slowing down. So we are speeding up from 0 to 2, then where else? Then from 9 to 10, and then from 15 to 16, right? And we're slowing down wherever acceleration and velocity have opposite signs. So that would be from 7 to 9, and we have 14 through 15. Yes, so this is how we find our speeding up and slowing down. Okay, so during what time interval is the speed the greatest? So whenever we talk about speed being the greatest, means what? Farthest away from the x-axis. So if I look at the graph, where am I farthest away? I'm farthest away up here, from 2 to 7, right? This distance, we're away and on the graph, and nowhere else is it that far on the graph, so it's at 20 there. So from the speed is the greatest is when we are at the interval from 2 to 7, and I'm going to explain the reason. Farthest from x-axis. Yes. A tree-toed sloth is hanging vertically from its tail on a horizontal tree branch high in the sky. The graph below describes the horizontal movement in inches of the sloth along the branch as it moves from left to right, with 0 corresponding to the middle of the branch. Time is measured in hours along the x-axis. So here we need to first determine what graph is given to us. Since it is the horizontal movement in inches, it is my position graph, right? So my y-axis are in inches and my x-axis units are measured in hours. And it's about the movement of the sloth. So let's get started with part A. It says, what is the displacement of the sloth during the first 3 hours? Basically, your displacement is the difference between where you ended from where you started. So my displacement would be S of B minus S of A. So what is my S of B? My first 3 hours would be S of 3 minus S of 0. I know S of 3 is what? 2. So it's going to be 2 minus 0, which is 2. So 2 inches. That's his displacement. And since the fact that it is positive, it means it's moving to the right hand side of where he started. Part B. What is the sloth's average velocity during the first 3 hours? Average velocity, we know, is S of 3 minus S of 0 over 3 minus 0. So I know S of 3 is what? 2 minus 0 over 3, which is 2 over 3. And since it's average velocity, it's going to be y-axis units over x-axis units, inches per hour. Part C. What is the sloth's speed at hour 3? So, and in what direction is he moving? So remember, speed is basically your absolute value of velocity, right? We want to find the absolute value at t equals 3 of velocity, and we'll have our speed. So how do we do that? So let's write this down here. So I know I want to find this. I want to find my speed at 3. So I'm going to basically be taking the absolute value. So my 3 is here. So if I find the absolute value between 4 and S of 2, and that will give me the speed at 3. So it's going to be S of 4 is 0 minus S of 2 is 4 over 2, which is, let me raise these markings, which is just negative 2. The negative 2, actually speed can't be negative, so that's why we do the absolute value. So it's going to be what? 2 inches per hour. And in which direction is he moving? The fact that this was negative means what? He's moving to the left. Part D. At what time or times does the sloth change its direction? So when does it change its direction? It changes direction when my velocity changes signs, right? So let's write that down. Changes signs. So I want to find when does velocity changes sign. So since it's a graph, we can just read off there. When is it going from positive to negative? When is my slope going from positive to negative? From 0 to 2, my slope was positive, and then from 2 to 4, it's negative. So at t equals 2, right, that would be 1, where it's going from positive to negative, and then at t equals 5, it's going from positive to negative, where the slope is changing here because it's not a velocity graph. So we need to look at different things. So D would be at t equals 2 and t equals 5. Part E. At what time is the slot the furthest from the center of the branch? So furthest means furthest away from the x-axis. So if I look at my graph, where is it furthest? It is furthest at over here at t equals 2. So part E would be, it is furthest away from the center is at t equals 2 hours, where he is 4 units, he's moved 4 units to the right. Right, it's not asking for the explanation, but it's good to know what we're looking at, right, where it's farthest from x-axis. And I always say, I like to do my justifications or my reasons first, because that's what helps me get to the answer. So now part F, how many total inches did the slot move during the 7-hour period? So let's do this. Distance is basically, we're going to go piece by piece and find out how much distance he traveled and no negatives. So we're not looking for displacement, we're looking for distance. So we're going to try at each interval from 0 to 2. He traveled a distance of what? 4 inches. Then from 2 to 4, he traveled a distance of another 4. From 4 to 5, he traveled a distance of what? 1, right? Remember, we're not ignoring the negatives. We're doing distance. And from 5 to 7, or we can do 5 to 6 is also another 1, and then 6 to 7 is also 1. If I add these numbers up, I have for F 2 plus, it's 4. It's 4 plus 4 plus 1 plus 1 plus 1, right? I messed up. Oh, I wrote 2 pluses, yes, which is equal to 11 inches. So finish up the remaining lesson, guys. If you have any questions, reach out. Good luck.